Cryptography and Privileged Access Management. And we would like to invite Chuck White from Fornetix. Chuck White is the CTO for Fornetix and is a technologist, inventor, and entrepreneur. He has extensive knowledge in cyber defense, collaboration solutions, big data analytics, and secure software development. He is a former U.S. Army officer, combat veteran, and recognized thought leader in the security software community. Let's welcome Chuck White.
Hello, everyone. Good morning, good afternoon, good evening from wherever you might be actually signing in. I'm Chuck White, CTO of Fornetix, and I'm really excited to talk to you today about this crazy thing called zero trust architecture. It's been around for a while, so is PKI, but now in the common parlance of designing, whether it's for IT infrastructure, OT infrastructure, IoT, it's in common. So we're going to talk about in a common parlance how PKI and zero trust architecture actually work. So, like doing an agenda, so let's talk about that agenda. We're going to go over a few things. And well, the idea being that we have what is in today's discussion. We're going to just go a little bit over NIST 800-207. That is the NIST specification of zero trust architecture. We're going to talk about zero trust and PKI. We're going to talk about how Vault Core supports PKI, and then a little bit discussion about reference architectures with a number of products for interacting with identity, credentialing, access management, and PKI as part of a zero trust architecture. So, without further ado, let's kick it off. Starting here is just the idea of what zero trust is, why it's important, and zero trust itself versus zero trust architecture. It's when you look at zero trust, it's the idea of implementing things based off of least privilege, being able to do it on a per request or per session basis, and then doing it in such a way so that you can minimize any sense of compromise. Now, we could talk about things like attribute-based access control, policy-based access control, what that might all mean in light of this, and we'll talk through that as we go through today, but just acknowledging that this concept of zero trust can be simplified. I don't trust a person, a thing, a device, a service, unless it has done something to attest that trust, and then I can go about actually showing it and make sure that we way to demonstrate that trust. Zero trust architecture is sort of add the A for architecture is what that looks like, that system of systems. We're going to talk about this time and again during today's talk, is that when we look at it, the realization is that zero trust architecture is a team sport. And that you'll hear me say this multiple times. And when we talk about things like policy engines and policy administrators, policy enforcement points, policy decision points, all the various technologies that slot in, per NIST 800-207, things like data access policy, PKI, ID management, your SIM infrastructure, things like continuous diagnostics and mitigation, industry compliance, threat intel, activity logs, they all kind of combine together into a way to feed this relationship between some things that want something and the things that have something, and how you can determine they should trust each other so they can communicate. So that's some pretty heady stuff. But I want to do some definitions of terms. I'm going to do a little bit of terms here just because people say zero trust, and that's a bit of a joke. I make the case that if you hadn't been working in this space previously, you will notice your zero trust became very popular about 5 minutes after blockchain was deemed an immature technology by Gartner. Not saying it is or isn't, I'm just saying the marketing emphasis towards zero trust happened, about 5 seconds afterwards. For some of us who've been doing this for a while, we all said, great, now everyone gets what we're actually doing, except that most times you could see zero trust gets bandied about, like poorly in the organizations. So I want to do some definition of terms of what are some of these critical components in the zero trust architecture, particularly the policy decision point, the policy engine, the policy administrator, and the policy enforcement point. So referencing, you're going to see from NIST 800-207 many times. but it sets the guideline of what's going on here. So why the policy engine and policy administrator make up what's called the policy decision point. Not demonstrating that I know the very smart audience that comes to encryption consulting events, so I'm not going to read for you, but I'll sum it up. The fact is that looking at these things, they define policy, they make it available to be consumed, that ultimately something that can consume it and make a decision, aka a policy enforcement point, can be used. So that gives you an idea to be able to see how these things all fit together. Bear in mind, you're going to see more of this as we go through the discussion, so this considers a way just to put in terms. But there are more terms to come. And particularly of all the security technologies that are mentioned, or techniques, capabilities, it is worth noting that PKI has a very specific role in terms of that public key infrastructure. Now, once again, we know PKI is all about trust, and it's a trust infrastructure, so we can see where, it would be a means of defining trust in a zero trust, a zero trust network, i.e. data from PKI, data provided from your PKI, actually could go into helping define, whether it's the outcome of what that policy decision point and policy enforcement point do, or merely become evidence of a relationship between a policy decision that's being made. Both actually play a critical role. It's also worth noting that there's some things that are said here. And this will play as we talk about more how Vault Core fits into all of this. Everyone who's waiting with bated breath. That the fact is we're talking about a few things. It's this idea of resources, subjects, services, and applications. And what it means, when are being used, how are they being used, and what that might look like. So once again, let's take it a step down a little bit further, and then we'll start talking about practical application. All right, resources, something you want. I want to access that device. I want to access that application. I want to access that service. That service is, so that's a resource. Subject, thing that actually wants to access that resource. And if you're familiar, yes, we see subject a lot in PKI. This also happens to be, it's being used here. It's a little bit of an overloading of a term, but that's okay. Similarly, a service is also slightly overloaded. In fact, it's so important it's mentioned twice in the NIST definitions. It is, if you think about the main relationship is resources and subjects. Services and applications happen to be things that can be a resource or be a subject, but are important particularly because when you think about this, it is going to be a resource, but internally it could also be a set of subjects and resources for how a system might actually communicate. So a service is effectively a system of systems. It can be very simple or very complex. And if you think about something like a cloud service or secure access services edge, SASE, greatest acronym in the current modern cybersecurity realm, containers, email systems, they're all more than just one thing. And in a zero trust architecture, an ideal end state is to address what all those things are and be able to make that decision about that. Applications, I use in this case an SSH client, just these are things that become part of the story. But what really is important is the combination of data about subjects and resources to equal trust. That's the important part, because that transitions to this. How does Vault Core help in zero trust architecture? We're going to go over some of these slides again, which we showed previously in the definition, but I'm going to apply a bit of a Vault Core twist. Now, for those who've been around and known us for a while, they've always known Vault Core has a policy engine. What they probably didn't recognize, for a number of different reasons, was the fact that we've been doing zero trust for a very long time. And you can take something, and if we apply our definitions in terms of zero trust and zero trust architecture to how Vault Core does things every day, this starts giving you that foundational component of a zero trust architecture. So I'm going to use PKI because what we're talking about zero trust and PKI and how the things slot in. So the 4 pillars of trust from a Vault Core perspective, we say, the DIRT equation. describe behaviors, interpret machine-to-machine policy, rate trustworthiness, and translate that policy for secure sharing. You know, God made dirt and dirt don't hurt. So a behavior, I want to create a key, I want to use a certificate, I want to do this thing, but for the sake of PKI, we're going to talk about what happens as one of our goals, what happens when your PKI takes on, not only supports zero trust, but takes on zero trust principles. Okay, great, I want to go do that. I want to interpret what that means about that request from a resource perspective and a subject's perspective. That gets into a trustworthiness rating. How do I rate that? And that's where what's the policy associated with the object, the key, the certificate, et cetera. What's the resource? What's the request? What is the subject requesting? How do those all fit? And then turn that ultimately into that decision point of will the transaction go forward or will it not? And so that's a baseline that helps feed into something. And it is worth noting that those attributes are really, it's an implementation of attribute-based access control, which has a strong association with zero trust architecture. So that ABAC controller is a core tenet of what a Vault Core appliance delivers, besides the crypto and PKI bits. And it can be applied in building out your zero trust architecture and supporting PKI to support your zero trust architecture. So we go back to our so a way to look at this is from an integration point, why we did what we did, the fact that Vault Core is in one half a policy decision point, and it also has policy enforcement point capabilities, particularly around cryptography. That's what that dirt equation we just talked about. And it's taking things like taking policy in. It's obviously, interacting with PKI. Vault Core is best described as a registration authority on steroids. It's interacting with ID management. This is where a lot of the API integration comes in. And then a SIEM system, security incident event monitoring. That is actually where you see a cross-section of the ability to interact, audit all these actions in very fine-grained in common event format for ease of use, and also have a feedback loop, because remember, there's also an automation engine buried in a Vault Core appliance to have the SIEM tell Vault Core how to change things. There's a lot of flexibility there, but it's also fitting into that 800-207 trust architecture, which is a great way to see how Vault Core works in the world. And things coming from the left, like stuff from continuous diagnostics and mitigation, industry compliance, threat intel, activity logs, that all becomes data that feeds through the system and it ultimately adapts how Vault Core will behave on the network. And so that's just, I think, an important part of this. So to consider how we help in zero trust, how the role we play, and that in particularly in PKI, we play multiple roles. So I just want to kind of take that as a step further. And I'm going to, it's one thing to show pretty pictures and say I do all these awesome things. I want to actually take this a step further based off of things that are happening in the real world and how these concepts are actually applied in real architecture. So one of the things, and you heard this, there's this team sport capability, is that, we call these coalitions of the willing, where companies band together to make innovative solutions. In this case, I'm going to talk through a few architectures about this. You'll see things like SailPoint, Thycotic, Radiant Logic, Exabeam, the Vault Core technology itself. But these are all references. These are building blocks. No one has a complete zero trust architecture, but it's important as industry that we find ways to help put these things together. Now, when you think about the intersection of PKI, and you think about how Vault Core works, you're going to think of, if you've seen things like this for a while out of Fornetix. And this is important because it also sort of establishes a cross-section of technologies. If you think about what we just talked about for zero trust, and we take it back a few steps, you're now seeing all these targets that are ripe for intersections of the zero trust architecture. This happens to be things that require zero trust, and things that interact with cryptography are much stronger relation than most people realize. And that's because cryptography into itself is authorization data. PKI is a representation of that authorization data for trust purposes. So making sure that this all kind of fits in becomes a critical point of doing this. And I mentioned a number of technologies here, and this is just mostly an idea of if you've interacted with the Fornetix team in the past, this gives you sort of the standard instant gratification, key management, cryptographic services type behavior that Vaultcore delivers. But it's important now, if you just think about everything we just discussed in terms of zero trust, what that means when you have a policy decision point controlling how cryptography gets distributed. That becomes some very interesting stuff and becomes a foundation, even in the basic enterprise IT use cases, to start building out those zero trust principles. Now, talk about PKI services. And I'm going to warn you guys, things get a little more exotic after this. It's really an exercise of understanding how Vaultcore fits in for PKI. Remember, we just talked about this, and I want to highlight a few things, like the fact that Vaultcore evaluates these requests and for certificates as a zero trust architecture policy decision point and policy enforcement point. It's the fact that it actually comes a way in that zero trust, remember, zero trust applied to PKI. Now you have a technology that actually has a policy construct for zero trust that's not only implementing zero trust principles for system security, it's also looking at things that would come from your policy authority, big B, big A, as in the policy authority for certification authority, and making sure that's being automated. And so now you think about this, a way to look at your certificate policy, your certificate practice statements. Vaultcore allows for much faster issue of certificates, which then fit into a broader PKI architecture as ways of saying, what are my systems, what are my subjects that need certificates, and what are my resources that need certificates? Are the certificates themselves providing the appropriate data so that they can form that broader zero trust architecture? So, and a number of vendors here, ever-growing list, that where you see the Vaultcore technology slotting in. And then we talked about this earlier, we talked about the architecture, the fact that SIMs are being interacted with, and that the Vaultcore automation, its controls, its boundary, its policy checks allow you to address this as effectively having a giant registration, having a registration authority on steroids that implements zero trust. That in turn lets you to use the foundation, the products of that, to build out a broader zero trust capability in the enterprise. So what does that look like? Next slide, starting to go into crazy town. But this is the realm of the real. So here's an example of Vaultcore with our partner Zigabyte, who specializes in those capabilities, actually doing what they do. Now, I'm going to go back to that in a second to kind of see where we're slotting in. The idea being in this broader architecture, PKI and the Vaultcore's ability to do attribute-based access control at ABAC controller ties into the API gateway. It takes data from authentication. And so the relationship here between our orchestration gateway technology, which helps us integrate with PKI systems, and then the ABAC controller nature of Vaultcore itself, ties in to let you actually slot in with a number of different technologies. This is a lot. This is a crazy eye chart, but this is actually based off of systems that have been deployed in the Department of Defense. And the thing being is, there's nothing crazy or government specific here. This is using commercial off-the-shelf technology to implement this. So it's not like it's any specialized software development. These are the products being integrated together for a specific purpose. We simplify that a bit. We can take a different look at this and sort of see this in a way that makes sense. And this is the idea for, like, in the case of the authentication space, you have things like privileged access management. You mentioned companies like Thycotic, Ping, SailPoint, et cetera. And in different cases, the Vaultcore technology is providing PKI services. It's doing that policy decision point or the release of public keys and like SSH-based authentication. And it's interacting, doing things like providing RNG seeds for things like Ping and technologies in that space. And ultimately, it's also plugging into the broader PKI for registration and revocations, all being driven by policy. Now, you can see a number of technologies that are involved there, But you can see this as an example of what ends up happening. This is a subset of the last slide. It's the architecture end to end. This is a slice of it around privileged access management. But there's more. This also applies to zero trust in terms of this data access and zero trust architectures. And you look at things like tools from like SailPoint, and what you're looking for is that they want the PKI services, and they also want something to tie into as that sort of that ABAC controller. So the fact that policy in terms of attribute-based access control and certificates, keys, they're all security objects. And that's really what we do at Fornetix, is we build a platform that's more for the orchestration of security objects. This happens to be PKI, certificate keys, secrets, all those things fit into the broad definition of security objects. You look at this model and you see a few things. One, that you see that there's not one technology doing all this here. This reference architecture, it requires multiple technologies integrated to solve the point. Also gets into things like why having open standards and APIs become critical. It allows you to facilitate building these more dynamic technologies, and allows for the team sport of zero trust to be executed in an intelligent way. It also gets into the fact that you're now talking about things for risk-based authentication. You're dealing with the universe of things that use security objects. Those zero trust principles end up being applied to all of them. And so now you see that foundation where you can start building your zero trust house on a foundation that's being provided with Fornetix technology, and that it represents an intersection of zero trust capabilities, your policy decision point, policy enforcement point, with control of cryptography type technologies like PKI, and putting them together so that you can actually build things on top of them. And a very simple way to look at this, to take the components and then put it into something that might be, you would see more on the one slide in PowerPoint, is this. The idea of where it all fits in. So people, you would think about Vault Core, yes, there's going to be the ability for key material and certificates. Got that. It's the purple line that becomes very interesting. That purple line represents policy decisions, authorization decisions, and leveraging not just the ability for cryptography, but access to the Vault Core policy decision point itself. And now suddenly you're getting the idea of the broad span on your zero trust architecture and your ICAM stack that's leveraging PKI for your zero trust architecture is having a coherent capability. Now, I picked a couple PKIs here. I mentioned Department of Defense PKI. For those who know what it is, it's a big nasty, and it's generally considered a headache to integrate with. But that being said, a lot of that is because it wasn't built with automation in mind. But if you're going to look at technology in a zero trust architecture that abides by the policy authority of DoD PKI, now suddenly you can start implementing, in enterprise PKI systems per what we talked about earlier. If we go back a bit and we could talk about what we were saying about the NIST 800-207, its example of enterprise, of PKI, it said that you could work with federal or Department of Defense PKI or other PKIs. And it's all about how you interpret the rules and regulations from a governing body known as the policy authority down through the technology, ultimately to the services that consume it. This is a very simple way of looking at it, but what you end up with is a cryptographic technology, something that has a FIP certificate, interacting with an application, a container stack that can consume what's coming out of that system, whether it's keys, certificates, or policy decisions itself, and rolling it into something that can be consumed by cloud services. In this case, things that we're talking about a multi-cloud agile virtual environment, which you can see the usual suspects like Amazon, Azure. Don't discount Google, stuff that Oracle is doing, or any number of other cloud vendors that have doing sort of one of the service offerings that could take advantage of technology that use identity. So this gives you an example of what this looks like in a little more simplified form of what the interactions end up being with. There's a separate line for identity, there's a line for PKI, and then there's a relationship here around authorization that can ultimately be projected into these various services. That's really the takeaway for this. And so the last piece is sort of, so we've talked a lot, and I have gone boom, 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 doing a pretty picture and slideshow, which is great because I love doing these things. Let's talk about, let's sum some things up here. One, first and foremost, PKI is an integral part of building a zero trust architecture. When we talk about the foundation, having a policy decision point and policy enforcement point in line with PKI helps. It helps a great deal, actually, because it allows that ability for trust to be put out to the network. Having PKI and ICAM joined at the hip for the sense of supporting zero trust architecture is incredibly, incredibly powerful. The first, last, most important, last, but certainly not least, zero trust architecture is a team sport. No one has a complete solution. And if someone tells you they do, politely ask them to leave because they probably don't. They don't. So no problem. It takes a relationship between vendors, service providers, integrators, us working together to actually make zero trust architecture with PKI, with other technologies together to make something that's feasible and usable. And that's the challenge to all of us, is that we all have to play nicely with others. And that's the trick to making these architectures viable for our customers. Thank you. I appreciate your time and look forward to hearing from you. Have a great day.